Hey guys, welcome back to my channel Learning Hub. So in this video, I'm going to talk about Bellman-Ford algorithm. So firstly, what is meant by this Bellman-Ford algorithm? Bellman-Ford algorithm is nothing but a shortest path finding algorithms, which is similar to Dijkstra's algorithm. See guys, Dijkstra's algorithm is having some limitations. So one of the most important limitation that Dijkstra's algorithm poses is so it cannot detect the shortest path between source and destination. So whenever there are negative weights involved in edges of a graph, okay, so but this limitation can be overcome by this Bellman-Ford algorithm. So why, how bro, how it is overcome? Because Bellman-Ford algorithm successfully detects the negative cycles that are present in graph. So what is meant by, firstly, what is meant by this negative cycles? See guys, for example, so let's think there are three nodes, A which points to B and B which points to C, and C, from C it points to again A. Okay. So now let's think there are edge weights that are present in a negative form. So first one is from A to B it is -2 and B to C it is 2, and from A to C again -1. So guys, the negative cycle is nothing but, so if we sum, 1 minute, I have -1. So here the total sum of the edge weights from source node to again destination node. So here source and destination nodes are same, which is A. So that's why it is called as a cycle. So this is another type of graph. Okay, so if you wanted to find the different types of graphs and how BFS and DFS is implemented and how graph is implemented, then please do check out my video, first video on this graph series that I have given in the description. Okay, now coming to the topic guys. So here when we sum the total edge weights, -2 +2 and -1, which results in -1. So here we got a negative number. The total sum of the edge of the cycle is a negative number. So that's why it is called as negative cycle guys. So Dijkstra's algorithm, it fails to detect these type of negative cycles. So that's why it won't give the correct answer, correct shortest distance between source and destination. But whereas this Bellman-Ford algorithm, it successfully detects the negative cycles and successfully gives the shortest distance between source and destination. So now without further waiting, let's jump into the theoretical session of how Bellman-Ford algorithm works. So now without further ado, let's get started. So guys, now let's try to go through the algorithmic part of this Bellman-Ford algorithm. Okay. So the first step of this algorithm is initialization. See guys, the initialization process in this Bellman-Ford algorithm is similar to the Dijkstra's algorithm. But in Dijkstra's algorithm, we use mostly two important data structures. One is priority queue and another one is a distances, normal distances map. So, but here we don't use priority queue. Here we only use distances map. That's it. So it's a map, right? So the second step is relaxation process. See guys, relaxation process is if the distance from source plus the new weight less than if distance of destination node, right? Then we perform an operation which is the distance of V is equals to distance of U plus W. See guys, this operation is called as relaxation operation. Okay, this operation is called as relaxation operation. And not only that, we try to relax each and every edge present in a graph. So we use a for loop. Okay, 1 I less than v minus 1 I plus plus. So this whole process is called as relaxation process, and this step actually relaxes the destination node, each node. Okay, So that's why it is called as relaxation node, relaxation process. And the third step is detecting a negative cycle. See, another most important point is, see guys, here we are iterating it v minus 1 times. See, okay, we are iterating it v minus 1 times, right? So why only v minus 1 times means, see, for example, let's take a graph A, which points to B, and B points to C, and C points to D. And from A, sorry, and from B, it also points to D, and from A, it points to D. So here, let's find the shortest paths from A to D. Okay. So if this edge is present, so when this type of graph is present, right? So the shortest path is A to D. Okay. And if this edge is not present, right? Then the shortest path becomes A to B and B to D. This is the shortest path. And if this edge also is not present, right? Then the shortest path becomes A to B, B to C, and C to D. So count the number of shortest paths, which is 3, and the number of nodes are 4. So that's why I have said we are iterating it v minus 1 times, because we need to find all the shortest paths, all the all the shortest paths from source to destination node. Okay, so that's why I have said v minus 1, which is 3. So that's why we are iterating it v minus 1 times. And the last step is detecting a negative cycle. This is the third step, detecting a negative cycle. So how we actually detect a negative cycle? So after performing this relaxation process v minus 1 times, all the distances will be optimal distances. And if there are any negative cycles, negative edges that are present in a graph, then after performing this step, it successfully detects the node which is having a negative cycle, okay, which is having a negative weight. So for successfully detecting a negative cycle, you can use this type of loop, and if we found that there is one edge that is still relaxing, right? So that edge is called as a negative edge. Okay, so we have successfully found that there is a negative edge or negative weight in the graph. So hence we detected a negative cycle. If we found that there is a negative cycle indication, then there are two cases. So the first case is, if the source and destination are associated with the negative cycle, then we need to correct that negative cycle. If we don't correct that negative cycle, then we have a chance of getting wrong shortest paths. So if there is a negative cycle and that is associated between source and destination, then we need to correct that. If another case is not association, if the source and destination nodes are not associated with the, not are not connected with the negative cycle, right, then there is no need to worry about it. The results that are queried will be optimal, will get the shortest distances. Okay, and the fourth step is nothing but the results step. So we print out the results based upon a detection of negative cycle, and if that there is a negative cycle and the results are not optimal, there is no negative cycle in a graph, then we can just print out the results. So now let us go to our coding phase. So guys, now let us jump to coding session. So firstly, I need to draw the graph, right? So so whatever the graph that we used in our Dijkstra's algorithm, we just modify this type of graph. Okay. So now the same graph will be using like, firstly the graph will be like A. From A to there is an edge to B, one more thing, and from B to C, and here to 4, and from B to D, B to E, and C to E. So here minus 5, 3, and 2, and from here to F, the weight that is acting upon D to F is 2, and from E to F is minus 3, and from F to G and H. And here, so from F to G the weight is 1, and from F to H it is 2, and from G to H it is 1 again. So this is the graph that we actually use in our coding session. Okay, so now let's jump into coding session. Oops, the earlier Dijkstra's algorithm graph, sorry, Dijkstra's algorithm code. Yeah, I will create a new one. Now let me name this with uh, or else I'll name this Bellman-Ford algo. Yeah. Let me write another algorithm also. Sorry, another function. So which is a static void Bellman-Ford. Okay, and this accepts map, where a map like string that we have created earlier in Dijkstra's algorithm, right? So the same graph I'm using here also, but only modification is the values. Map and string graph, comma. I need to import it, right? Java dot util dot star. And one more thing is I need to create edge, right? So the same thing, I'm actually not creating it. So I'm just copying it from, okay, I created an edge. And again, I just wanted to create, wanted to copy the same data structure that I used to create a graph. Now I wanted to modify the values. Let me see, from A to B it is 2 and A to C it is 4. From A to B it is 2, right? Now let us write the actual algorithm, okay? So firstly, the first step is, as I said, initialization. So firstly, we need to initialize the distances map, right? So let us create map ring, yeah, string comma, and the other is integer distances is equals to new hash map. And now let us try to assign the values. And another one is int v is equals to, I need to assign the size of the graph to the variable graph dot. So let this be capital V, okay, for better understanding. This would be node, and this would be graph dot key set. I'm trying to actually keep all the distances to infinite initially. So distances dot put source, and this would be integer dot not source. Here I need to node, yes, integer dot max value. So after the initialization step is completed, so now we need to relax. So for relaxing, I have said that we need to relax the operations or relax the edges v minus 1 time. So that's why I'm creating a for loop for int I is equals to 0, I less than v, I plus plus, and now the loop will be running on v minus 1 times. So I need to now find out edges for each of the node, right? So for that I need to iterate it over key set times. So how many nodes are there? So those many times I need to iterate. For that, uh, for string, yes, from graph dot key set here for edge e from, yeah, this is a source, right? So I might write u distances. Okay, okay. So for edge of e, graph dot get, so now int eight is equals to e dot weight, and then int dest, sorry, it's not int, it's a string, e dot dest. And now the relaxation operation. So if distances dot get of u plus eight, if this weight is less than distances dot get test, then we will relax the edge distances dot dest to. So that's relaxation operation. And our next step is detecting a negative cycle. So as I said from graph, so when you are in a loop, right, so the distance will always try to reduce on every turn, on every relaxation operation. The distance will be, the edge weight will be decreasing to negative infinity. So if it is decreased, so after all relaxation operations of a v minus 1 times, so we need to iterate another v times, so such that we can actually know whether there is a negative cycle involved in the graph or not. Okay, now let us detect the negative cycle. Okay, so for that we will be initializing a variable, a boolean variable. So if there is a negative cycle, then this boolean variable will be true. If there is not, then it will be remained same, which is false. And now let us write the code for negative cycle detection. For so for correctly identifying the negative cycle detection, we need to again relax the whole graph. For that, I'm just copying and pasting this. Okay, so this is a relaxation operation. Again, we will not modify this now. So instead what we are doing is we are just modifying the boolean value to true, and now finally printing the results. That's it. Print results. So for printing the results, what I'm doing is I'm just creating a for loop. For I'm trying to print the results. So now for string u from distances dot key set, be getting a distances, and now will be system dot out dot println. Now what we will be doing is node dot, sorry, distances dot get node, and that's it. Now if not, so if the negative cycle is true, right, if it is true, right, so then we will be printing system dot out dot println the results are not reliable because there is a negative cycle. That's it. Instances dot put source to 0. Yeah, that's it, guys. Now let us check the result. Yes, that's it. We got it. So this is what a Bellman-Ford algorithm, guys. So it detects, successfully detects the negative cycle, and also it calculates the shortest distance if there is no negative cycle and negative edges. So that's what the algorithm is. So now, guys, if you like this video, then please do like this video and subscribe my channel Learning Hubs, and share this video with your friends, so it would be a better support for me. So that's from my side. So yeah, thank you and happy coding.
Thank you for watching, and I'll see you next video. Happy coding.